Like I was saying, the topic is simple harmonic motion. Here we talked about how we define it. We said whenever you are trying to define simple harmonic motion, you don't miss the two conditions, because if you miss one of them, it means your definition is incomplete. And one thing we also emphasized is that you can find the velocity and the acceleration. With the velocity, you can either use this shortcut or you can use the standard formula, which starts with V equals W under the root of open brackets r squared minus x squared. So one thing we emphasize is that you make sure that you have the correct value for x, because that is the displacement, and you've interpreted correctly the amplitude or the radius. So maximum conditions, when you have the velocity, the maximum velocity, it happens at x equals 0. So this is why Vmax is this one we have here. Vmax equals WR. And one thing I mentioned is that when you go back and substitute in that formula, it will definitely give you what we have here. So acceleration is almost the same formula, but where there is R, or rather where there is X, we square the W, and also we put the X there. Instead of using the root, we just say W squared, then the displacement. This is the acceleration at any given point. If you're looking for the maximum acceleration, then it's W squared R. So here, this can even go away. And then we say W, this is deleted. Then we said squared. So the square is here. W squared R. Let me just write it here. Okay. That is maximum acceleration. The other two are time and frequency. Periodic time, you get 2 pi divided by omega, which is the angular velocity. Periodic time is found like that. But if you're looking for frequency, which can be represented by F or N as we put it there, you do the opposite of this, because frequency refers to the number of cycles that you generate in each unit time or per unit time. Whereas periodic time is the amount of time taken to complete a cycle. Of course, it's in seconds. Okay, then the last thing is just that the amplitude is the maximum value of your displacement. That's about the items we need in this analysis. Okay, unless there's something you need to clarify there, but those are the ones. From there, can we proceed to review that example we had started? Let me just delete this also. Oh, you're not able to hear me? Hello? Yes. So it's coming and it's cutting. Oh, okay. I see. Okay. All right. Okay. Otherwise, the beauty is that the whole lesson is being recorded, but either way, I'll try to be, in case maybe it's low, I'll try to make sure that my voice is strong enough. I hope that improves the whole thing, yes. Okay. But when you notice it's too quiet for too long, you can feel free to notify me, because from here I'm able to get you very clear. So here I'm able to type. Okay, no, I will try to make it stable throughout. I will try to make sure it's maintained. Okay. So the question is, we have a crank of 40 millimeter long, driven by a piston, and makes 1,400 revolutions per minute. And of course, the condition is that it's simple harmonic, and it's 9 millimeters from the end of the stroke. Then we're told to calculate the acceleration, maximum velocity, maximum acceleration, and the frequency, and finally the periodic time. So one thing I emphasized here was that this question was a bit, it had some information that was hidden. The X was not given directly. They told, what was explained in the question was that this is 9 millimeters from the end of the stroke, not 9 millimeters from the mid position. So as a result, we cannot use this 9 millimeters as X. And the 40 millimeters, converting it to meters, we said we divide by what number? Converting to millimeters, we divide by what number from millimeters to meters? Mr. Guardian? Okay, yes, I was saying when we are converting from millimeters to meters. Okay, okay, okay. I think we'll see. Millimeters to meters. If we have to convert from millimeters to meters. Yes, millimeters. Converting it to meters. We divide by what number? To meters. Correct, that's 1,000. So from the same, that's how come we have 40 millimeters becoming 0.04, 9 millimeters becoming 0.09 there. And to get the X, all we do is subtract, because this was 9 millimeters from the TDC, or from the end of the stroke. So when you say 0.04 minus 0.009, the answer comes out as 0.031. Of course, here, what I mentioned was that the handout... 0.031. Correct. Thank you. Then the other one is the 1,400 revolutions per minute. To convert it to revolutions, or rather rads per second, we use this formula 2 pi n over 60. So 2 pi times 1,400 divided by 60. Again, I don't know if you have a calculator where you are. Do you have a calculator there? Yeah, 2 pi times 1,400. Yes, sir. Great. Okay, good. Thank you. Correct. Divide by 60. It's 1.5. Yes. 1.5.66. Okay, so 2 pi, you multiply by which one? By 1,400. You multiply by which one? 2. 2 pi times 1,400. Then you divide by 60. Yes. Okay, it's correct. Excellent. Thank you. Then, of course, we've already. Thank you. That's correct. Thank you. So the next one we have is R, which is 0.04. This one we already went through it. We can pick up the first one. So the first question is asking for the acceleration. Yes, so what I said was that the acceleration, it means that our solution was this one, which was looking like part B. That's the first one. Acceleration is W, correct, W squared X. So meaning 146.61 squared times 0.031. 146.61 squared times, or rather we multiply by 0.031. Yes, yes. 0.01. Sorry, 0.031. Sorry. It's working out. Okay, no problem. No problem. We'll manage bit by bit. So 146.61 squared, then multiply by 0.031. You can feel free to use that calculator. Sorry? Yes, I can hear you. Yes, you can go ahead. Oh, you want to? Hello, yes. Oh, you've already gone to maximum acceleration. Okay, thank you. So the first one has given you 666.32. Okay, okay, great. Yeah, the maximum acceleration, that's good. You just substitute. Instead of 0.031, you use 0.04. So it's now 146.61 by 0.04. Is it giving out 859 or something else? Hello, sir. Yes, I can hear you. So the one for maximum acceleration, is it okay? Or... Yes, I'm getting maximum velocity now. Yes, we proceed with the maximum velocity, then we'll follow with the maximum acceleration. Okay, thank you. So with the maximum velocity is just WR. So 146.61, you multiply it by 0.04. And the answers that you find here for Vmax should be higher than the other velocity, which is just a normal one. So maximum velocity 146.61 times 0.04. You should be getting, it's supposed to give you 5.864 meters per second. Okay. The other one, which is C, although this one wasn't the frequency, although part A wasn't there, but if we had been required to find the velocity, this is how we could have gone about it. And when you compare A and what we have here, you notice the number here is smaller. When you're asked to find any velocity, the maximum should always be the bigger value. Let's pick up the frequency. The next part is asking for frequency. So frequency, it's W divided by 2 pi. In other words, omega divided by 2 pi. We're talking about the angular velocity in radians per second, then we divide by that product there, which is 2 pi. So 146.61 divided by 2 pi. Again, you can verify if it doesn't give you 23.334, then we can see if there are any problems there. Are you using a calculator or are you using the calculator from your phone or the actual scientific calculator? Mr. Boya? You can start for me. The panel is not okay. 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 You want, okay. Here we are. I'm on here. Yes. Yes, it's here. Okay. Let me see. Like that. Has that improved it? And this, yeah, this is right. Okay. Yes, sir. Okay. Thank you. Okay. Yes, so in the case of frequency, we are saying 146.61, then we divide by 2 pi. You can also try to verify that 23.334 Hz is correct. This is for periodic time. And remember what we said is that periodic time, or rather frequency, frequency refers to the number of cycles generated per second or per unit time. Meaning, if we are talking about an engine, it means it has managed to make 23.334 cycles during a period of 1 second. But let's see, is your calculator verifying, is that correct? 23.334? On the frequency? Okay, I'm sure you, from there when done, you can feel free now to proceed to the opposite of that, which is the periodic time. Periodic time, you just swap the values, rather swap the variables also. So here we have 2 pi divided by omega. Now the 2 pi, remember is just a full number, 3.142. You don't need to struggle with it because it's already there on your calculator. So we're saying 2 pi divided by 146.61. How much time is it taking to complete one cycle? So when you divide again, depending on the accuracy, that is the answer we should find, 0.0428 seconds. 0.0428 seconds. Of course, it means that in 1 minute, a lot of these cycles will be completed. Okay. I hope you're still able to hear me, Mr. Kasamika. Okay, right. So these were the last two that we were referring to. We have had, first of all, the frequency, the periodic time. Now let me just try to summarize this so that we get things straight. The first one talks about the acceleration. Um, it's like we had included an extra one, which is for velocity. When you're calculating for velocity, you still use V equals W R squared minus X squared. The W is 146.61. Then R is 0.04. So we square it as well. Take away 0.031, also squared. And when you do that, you make sure they're in the brackets. Then the answer will be 3.7. You continue with acceleration, and you get your acceleration as 6.32. This is just acceleration, not the maximum one. So W squared X refers to just the acceleration. But if you proceed with the next one, it talks about the maximum acceleration. With the maximum acceleration, where you have X, you substitute it with R there. And you just proceed with the same working, so it becomes W squared R. The R is 0.04, so you say 146.61 squared multiplied by 0.04. That is your maximum acceleration. The unit is meters per second squared. I think my computer was just giving some funny values there, but otherwise it's supposed to be squared. So 859.78 becomes the maximum acceleration. If you look at the other normal one, it was 666.32. But this one is 859.78. You can already see the difference in numbers. The maximum value must always be bigger. If it gives you the opposite, then you should be able to know that there is a problem and you have to check your working. Of course, the maximum velocity is just V max is WR. So you just multiply 146.61 by 0.04. The first answer we had for velocity was 3.7 meters per second. But this one should give you 5.864 meters per second. And if you notice the two values, one of them is maximum. This one is maximum, so it's bigger. And that's how come you have 5.864. Now, having found velocity and acceleration, the most obvious is you also need to find the frequency. The frequency is the one we said it has to be angular velocity following the unit divided by 2 pi. So what we had was 146.61, then we're dividing by 2 pi. When you do that, it has to give you 23.334 Hz. That is the value, whether the SI unit for frequency, representing that value. The opposite of frequency, or frequency, has its reciprocal as periodic time. So periodic time is given by 2 pi divided by omega. So we're getting the 2 pi divided by 146.61. Of course, you can see that when you say 2 by pi, the value should be 6 point something. So if you divide by 146.61, the number you should get is supposed to be less than 1. And there we are. The answer is t equals 0.0428 seconds. That is our periodic time in seconds. Now, below here, this is just a mini exercise that I would want you to look at. They are just, alright, 5 questions, and looking at a variety of issues. Some of them already have answers, others don't. The question number 2 is asking for the inertial force given that mass. So here you just use the formula F is equal to ma and do the substitutions accordingly. Okay. Now what I would want you to do is, first of all, try to do the exercise. Like I had said, I will try to update the handouts and share it again so that those small typo errors can be cleaned up. And as you do the exercise and go through, I think things should be able to settle together. Okay.